Hello everyone, I hope you are doing well. In this video, we are going to solve problem 125. And in this problem, the problem wants us to verify a string to find out is it palindrome or it's not. So let's start with the problem. So here we have an input string, a man, a plan, a canal, Panama. So let's see is this palindrome or not. So if we want to check this string is palindrome or not, we need to first remove unprintable characters in the string. For example, if you check, we have if I write it here again, a man, a plan, a canal, Panama. First, we need to remove unprintable characters and space. For example, this one, this one, this one. We have several unprintable characters here. After we remove all these characters, we get to the string like this. What we should do after that? If you see, we have some uppercase letters here. We need to change these letters to lowercase. So the result will be a man, a plan, canal, and Panama. The, the palindrome string is a string that we can read it from different way in the same way. If you check, we have A, we have A, we have N, we have N. Then we have A, we have A again. Then we have N, we have N. And if you continue, you will see that we will get to the middle of the string and all characters are equal from left and right. So as you see, from the beginning, we did some cleanup. After that, we did the cleanup, we get to this string. And when we get to this string, we have an index that start from the left, then we have the other index that start from the right, and we start increasing the index that is in the left side, move it one step to the right, and move the index that we have on the right side, move it one index to the left until they pass each other. So let's do the same things in the code. Let me clean this one. Okay. Okay. As I show you, what we need to do the first. If we name the method something like is palindrome. So I'm starting to write the method. I name the method as a public boolean. I name it is palindrome. And this method received the string s as an input. So first thing is first, as you saw, we did the first cleanup on the input string. So we need to do the same thing. Assume that we have a method that do the cleanup for us. So I'm doing the cleanup first. I think that I have a method. I name it clean and uppercase to lowercase. And this method received the string that we received in the input and will do the cleanup, remove on all the unreadable characters, remove all the characters that we don't want, then change all the characters in the uppercase to the lowercase, and return the result, we will persist the same result in the new storage that I name it S. Then as you see, we had two pointer. One of them work from the left, one of them work from the right. So I need to define the two pointer, left and then right. The right pointer is the pointer that point to the last character of the cleaned string. And as you know, always engineers count from zero, so we need to reduce the one here. Then we need to have a loop. And as long as that the criteria will be valid, we need to continue the loop. And we need to check and make sure the left is always the left pointer, never past the right pointer. So what we need to do here, I put something like this here. I need to check if S dot character that is at the left pointer equal character that is on the right pointer. We will define, but I'm not going to check the equality. I'm going to check if it's not equal. So if I, for example, I have a string like this, a man, B, C, just it should be like this. I start the left from here, right from here. I then move to this. I just move one by one until I get to this position. I'm checking, is the character that on the left pointer equal the character on the right pointer? As you see, here is a B and here is a C. So this string is not palindrome. So the method could be returned without, if there is another character in between, we don't need to check those characters. And we can return the false as a result. So in this case, this method could return false. In the other case, I need to just increase the left and decrease the right pointer. I can close this one. And if if this criteria will be true for all the strings, we can return true. So this is the body and the structure of the main method that we have to check the string that we have is palindrome or not. But as you see, we made the assumption and we define the method clean and make uppercase to lowercase. And in this case, we need to define this method too. So keep this one here. This is the main method that we have. And let's start implementing the cleanup method. Maybe it's better. I like to keep this area. So I'm going to define the other method. And this method return a string. The name is clean and uppercase to lowercase. And this method accepts another string as the input. What I want to do, first I want to remove all the characters that not readable, not printable. So I just defined a string builder here, and this string builder will be the temporary memory result, and then I need a loop, and this loop should start from the beginning to the end of the string to remove unnecessary characters and change each character from lowercase to uppercase. So I need a loop here. And this loop, as I told you, start from the first character at the string until the last character at the string. This one doesn't work. So I'm going to define the CHR, and I'm going to read the character that this pointer point to it on the string. S dot char at I, and then I need to check, is this character is the valid character, is this character is one of the readable characters. And how can I do that? If you check here, I write the ASCII character of the digit, uppercase character, lowercase characters, and if you check here, each character has an integer value in the ASCII table. For example, digits start from the ASCII code 48 till 57. Uppercase letters start from 65 to 19. Lowercase letters start from 97 to 122. So if I have this ASCII table and I check each character that I read here, this is the character. And the value is the character, is the one of the decimal values that I have here. I can validate, is the character in the valid range or not. So I do the same checking here. I just add a method here. If this character that I read it here is less than 48, less than 48 means it's in the upper bound, or more than 122 after the lower case. So I don't need to check these characters. I can skip these characters. What else do I need to check? For example, this is the first one. Then I need to make, if you see here, between 57 and 65, there's a gap. Between 90 and 97, there is a gap. So there are some characters in between here. There are some characters in between here. I don't need to have these characters in my result listing. So I can skip those characters too. So if character is bigger than 57, yeah, and character is less than 65, or character is bigger than 19, or character is less than 97. Okay. Here, oh, I can continue the loop. So what I did here in this section, I just checked, is the character that I have is before the digits or after the lowercase? Is the character that I get here is in this area or in this gap area that I have here? So if the character is in these areas, I can skip that character and assume it as a non-printable character. So this is something that I did here. After that, I need to change the characters from the uppercase to lowercase. How can I do that? If you check here, the uppercase character for A starts from 65. The lowercase starts from 97. So the difference between the lowercase character and uppercase character is 32. So if I just, someone give me the uppercase character, if I added 32 to it, I could change it to the lowercase. So let's do the same thing. Then I can check if CHR is in the boundary of the low, uppercase characters, and the CHR is less than 91. So this is the boundary of the uppercase characters. I can do this. I can do just add the 32 to the value of that character and change it from the uppercase to the lowercase. And after that, I just easily resolve, append CHR. And then, oh, I should close, this is the loop. Then I can close the loop and I can just return result to a string. So, as you see, this is the complete solution for this problem. I just did the cleanup, then I defined two pointers, one moves from the left, one moves from the right, and then I defined the method for cleanup and just check the boundary of the ASCII characters and remove unwanted characters, change the characters from uppercase to lowercase, and that's it. This is the easy peasy solution. So, what is the time complexity and the space complexity of this project? So, just for a second, skip this one. Here I have a loop here, and this loop gives me the idea that the execution time is O n. But as you see here, I have the other loop here. This is O n, so O n plus O n always equal to O n. But if you check here, I named this same variable here, but think that this one, I named this one instead of s as a t. So it's a new space that I get in the memory. I have the s. Then I define this another memory with the same size of the s to persist the cleanup string in that one. Think in the worst case, all the letters that we get in the S are lowercase and there is no unprintable character. So the S will be the same, the T will be the same size as the S. So in this case, I add the additional memory with the same size of the S to keep the cleaned string in it. And if you think a string could, in the implementation for the string behind the sense is the array of characters. So I define the array with the same size of the initial array to keep the clean string. So I can say that time complexity of this solution is O n. And the space complexity of this solution is O n because I defined the other memory with the same size of the initial string that I received. And if I assume that a string implementation is by array, I define the array with the length of n to keep the cleaned string. So this is a solution for problem 125. I hope you like this video. If you like to see how we could improve this solution, in the next video I will show you how you can reduce the space complexity from O(n) to O(1). If you like this video, please subscribe and continue me on the next video.